Welcome back everyone. Objective of this session is to understand possible things we can do in the CAE and how CAE is able to do all these things. So far we know that CAE stands for Computer Aided Engineering. In CAE we make use of computer softwares to simulate the performance in order to improve the product design or assist in the resolution of engineering problem for a wide range of industries. Now let us try to understand the important term in this definition. First important term we have is the computer software. Instead of computer software, many people call the computer tools also. So keep in mind, for this course I will be using the software and the tool as the interchangeable terms. When we talk about the computer software, it will include HyperWorks, Abacus, ANSYS Workbench, LS-DYNA, Nastran, and there are so many of them. So using these tools, we are going to simulate the performance. Now let us try to understand what I mean by the simulating a performance. With the help of CAE tool, we will try to mimic the physical behavior of a component using the boundary and the loading condition. That is nothing but simulating a performance. Now why we want to do it? Of course, we want to improve the product design and assist in the resolution of engineering problem. So let us understand this improve the product design term. If you remember, in our first session, at the time of discussing the PLM cycle, we stated that everything starts with the need, and that need is nothing but our problem. So in order to resolve those problems, we can make use of computer tools. And the last term we have over here is the wide range of industries. Now close your eyes for a moment and imagine any industry, be it automotive, aerospace, medical, transportation, any of the industry that you can imagine. We can implement the CAE tool in that industry. So I hope you got the scope of CAE. In CAE, we can do multiple things such as simulation that we have just discussed. So with the simulation, we will try to mimic the physical behavior using the loading and boundary condition. Second thing that we can do is the validation. Validation simply means whether the component is going to fail or not. So to do that, we might check whether the stresses are exceeding the yield limit or ultimate limit, or we might check the fatigue life of a component. Third and one of the important thing that we can do in the CAE is the optimization of product. In recent year, more and more organizations are doing the optimization. So with the optimization, we will start with very simple shape. For that shape, we will apply some constraint in terms of how much load it has to sustain, how should be the stress distribution, what should be the frequency of the end product, which manufacturing method we are going to employ. So all these constraints we are going to define. Once we define all these constraints and specify the design space, then at the end the software will give us the final design of the product. Another important thing that we can do with the CAE is the simulation of various manufacturing processes. So you might have heard of the organizations doing mold flow analysis, casting analysis, then various G-code and M-code creation. So multiple manufacturing processes can be done in the CAE also. Now let us discuss how CAE is able to do all these things. Well, we know that CAE employs the numerical method in order to get the solution. There are n number of numerical methods that can be employed, but specifically under the CAE, we can use the numerical method such as FEM, or which is also known as an FEA. Both the terms are one and the same. FEM term is more popular in the universities while FEA is more popular in the organizations. FEM stands for finite element method and the FEA stands for finite element analysis. Keep in mind, both the terms are exactly same. As their name suggests, finite. Finite means basically we are going to discretize our geometry in the form of element and we will perform the calculation at only finite number of points. Here I just want to clarify one thing. Many people will say CAE is exactly same as an FEM. Well, technically that's not completely incorrect, but unfortunately that is not also completely correct. FEM is just small part of the CAE. Under the CAE, there are multiple other numerical methods which can be employed to solve the complex problem. So keep in mind, CAE is very broad term as compared to FEM. Next numerical method that we have is known as an BEM, that is boundary element method. Third one we have is the FEM, which is known as an finite volume method, and fourth one that we have is known as an FDM, which stands for finite difference method. In the next session, we will briefly talk about this numerical method. As of now, keep in mind, CAE uses the numerical method to get the solution. Depending upon the problem, it might employ FEM, BEM or FEM. Generally, we don't use FDM method in the CAE, but still it is possible to employ the FDM in the CAE as well. At this moment of time, I will highly encourage you not to get demotivated by seeing so much numerical method. Though there is a fundamental difference in working of this numerical method, at the bottom or at the foundation, they all do the same task. That means they will discretize our geometry, and instead of performing the calculation at infinite number of points, they will perform the calculation at the definite points only. Now let us move our discussion to the domains in CAE. In general, there are 5 most popular domains in the CAE. Of course, CAE is very broad term and there are n number of industries to which we can employ the CAE. This discussion is mostly applicable to the automotive and aerospace industry. So as you can see on your screen, in case of automotive industry, these are the 5 most popular domains. So let us try to get familiar with each of these so that at the end of this course you can decide which domain you like the most. First we have is the durability or the fatigue. Generally, whenever you buy any product, that product usually comes with the warranty. As the name suggests, durability, that simply means how much will be the lifespan of the product or how long the product is going to be durable. Let us try to take another example. During the lifespan of a vehicle, we close and open door multiple times. So if we consider longer duration of the time, closing and opening will constitute a fatigue loading. So while evaluating a product, we will have to consider all these situations. Not only that, if you think about it, generally if you are in hurry or you are angry, then you might smash the door closed. So in those cases, we will be applying more force as compared to our regular operating force. So this type of loading is known as an abuse type of loading. So all these loading conditions will be simulated under the durability and the fatigue. I hope you got the little bit idea about the durability and fatigue. Now let us move our discussion to the NVH. NVH stands for noise, vibration and harshness. NVH people will make sure that your structure has a sufficient stiffness. Not only this, they will also take care of noise level in the product. In recent days, NVH has lots of opening, but there are not sufficient people available in this domain. So in terms of job opportunity, there are huge job opportunities available in the NVH. Let us move ahead and have the discussion related to the crash. The people in the crash domain will make sure that the occupant will be safe in terms of the crash event. So they will be responsible for doing the load cases such as front crash, side impact, roof crush and n number of events. Next domain we have is MBD. MBD is nothing but multi-body dynamics. If you have a passion about engineering mechanics, theory of machine, then this is your team. These guys basically simulate the mechanism and the forces that will come onto the joint. Generally, the loads that we apply in the durability and fatigue, those loads were derived from the MBD team. And last we have is the CFD, which stands for Computational Fluid Dynamics. Keep in mind, in most of the cases, in order to go to the CFD team, you will require the post-graduation. People in the CFD team will be responsible for the various fluid flow simulations, then calculating the drag and lift on the aeroplane, calculating the fuel efficiency, and there are many more things that can be done in the CFD. Hope you got the better idea about the different domains in the CAE. Now let me quickly brief you about the tools which are used in this domain. In durability and fatigue, mostly we will be using Hypermesh, ANSA, Abacus, Nastran and Sys Workbench. For the fatigue exclusively, we can go for the ENCODE, FEMFAT also. In case of NVH, again we will be using the Hypermesh and ANSA, which is the preprocessor and which is common for all the domain. So Hypermesh, ANSA and most popular is the Nastran and OptiStruct, which are employed in the NVH domain. For the crash, we will be mostly using the LS-DYNA and the PAM crash along with Hypermesh and ANSA. For the MBD, mostly we will be using the MSc Adams. And for the CFD, again Hypermesh, ANSA, Star CCM+, ANSYS Fluent, and there are multiple others which are available. But these are the most commonly used tools in these particular domains. So I hope at the end of this session you got the little bit idea about each of these domains. So let us meet in the next session. Till then, take care. Goodbye.